Oh, how we doing, everybody? It's your boy, it's Joey. How we doing, everybody? Sorry for the wait. Just had to get some coffee. So, like we start every stream, make sure you got your learning caps on, and make sure. Oh! Turn that down. Make sure you got your coffee in hand. Coffee. Woo! Oh, that burns the fingers. How we doing, everybody? It's your boy, it's Joe. How we go? Ah, that's a spicy meatball. Oh yeah, I need some of that. Get that in your life. Nice and hot, nice and dark. Just the way I like it. All right, boys and girls. You know what time it is. You know what time it is. It's time to jump back in to CCNA exam study guide. We're going to get it in today, guys. All right? We're jumping in to part 3, chapter 8 tonight. All right? Hope y'all can stick with me all the way through to the end. Let's make it happen. Let's do a quick recap. All right. So, how was everybody's weekend? I hope it was good. Mine wasn't too bad, actually. What did I even do this weekend? Oh, I streamed a couple times. Streamed Saturday. Saturday was pretty good. We did some gaming on Saturday. I think what did I play on Saturday? Rage 2. That's a pretty fun game. Played a little bit of Starbound. That wasn't too bad. The controls were too much for me, so I kind of went back to Rage 2 afterwards. But Sunday was a fun day. Sunday I did a pretty what was it? Oh, we updated Cisco Modeling Lab to Cisco Modeling Lab 2.11. Which was an updated, which we had to update the entire VM for that. So what I did was I pretty much wiped that whole entire VM that we were using before. That was the Cisco Modeling Lab 2.1 VM, and then I went through the process of how easy it is to take the OVF file with the with the ISO reference file. The reference file, that's the one that has all the images for the routers, the switches, the Ubuntu desktop, the Ubuntu servers, and whatever else on there. We went right on my EXXI server there, and I showed you guys step by step how to spin it up. And then once we spun it up, from there we registered it. And then we created a whole new lab. We went through the step. We made a pretty in-depth Dhcp lab too. It was a lab that I had created a similar type topology lab a while ago. And what it is you take a we'll do a quick overview of how it is. So you take in the topology. How I do it is I have my router here, and then off that router, that one interface, this is like my server farm, all right? And then this is where I had my first server, and this was my DHCP server, all right? This is my server farm switch, all right? All right, and then what I do is I have this connected out to the real internet, okay? As a Nat Bridge, all right, on that connection, all right, and that's dynamically allocating an address to this router right here. But what I do to try to make this work as well as it can, even though this is going to be a DHCP server, I have this router dynamically allocating addresses to my server farm over here, giving it DHCP, all right, giving it DNS, all right, and gateways and stuff like that, all right. That way it's it's a smoother transition when I boot up this Linux, because this is an Ubuntu image. All right, that's an Ubuntu image right there. That's an Ubuntu server. All right, and that's the 20.04 image that DHCP server is running. All right, and then what I do is from here is I have a couple of switches. Okay, I have my main switch. All right, off my main switch, what I do is I break off a couple of VLANs. Okay, I have a VLAN 10. All right, and then I have a VLAN 20. Okay, and what I do from there is I make a couple. I add a couple of PCs to these VLANs. Okay, but then what I do is this DHCP server is going to be the DHCP router. The DHCP server for these two for those two VLANs right there. So what needs to happen is the messages, all the DHCP messages that are flowing through these two switches and then to the main switch, all right, come through this router, and then this DHCP server's got to get those messages and relay those messages back through those separate VLANs, okay? And that has to do with what we're going to be getting into, which is trunking, okay? Trunking, if I could spell tonight, trunking, VLANs, all right? Sub-interfaces. We're going to touch just on sub-interfaces, okay? All right? All right? And this is, so tonight we're going to be getting into what is a VLAN. And that was, VLANs are so, I guess, we have to understand the fundamentals of what a LAN is before we can understand what a VLAN is. And we kind of touched on the basics of what a LAN is, and that was all of what the first couple of chapters that we really took the big dive into from 1 to 7. Okay, all right, and what you have your LAN, all right, which is your local area network. All right, all right. So your local area network, that's your home. So you have your home. What you have, if you're at home right now, you got your laptop, and your laptop has an IP address of 192.168. Probably 0.105, maybe I'm just taking a guess. And then you have your cell phone, which is 192.168.0.106, maybe. All right. And then you maybe have your Amazon Fire Stick, which is 192.168.0.107, maybe. Now I'm just assuming, guys, okay? Now what the point I'm trying to get at is your local area network, okay? What that is referring to is your actual network, where you're residing, your broadcast, okay? Your broadcast area. Now, for instance, and again, this is just for instance, and I'm assuming, all right, you're all sitting on the /24 notation subnet mask, okay? And what that's going to tell me is this right here, this portion is your network. So 192.168.0, 192.168.0, 192.168.0. That is your local area network, okay? Your LAN. So these are your LANs, and this is your host. These are all your host addresses. So 105, 106, 107, these are hosts, all right? So that's your, this is your laptop. This is your iPhone, if I could spell tonight. This is your Fire Stick, all right? So all these addresses that you're going to see, again, this is just assuming that you're all you guys are sitting on the /24 subnet mask area, okay? These are your host addresses. This is your network addresses, okay? Now we're going to get into subnetting and stuff, I believe once we get into part 4, that's when we're going to get this to actual subnetting. Through part 3 though, we're going to be dealing with subnets, okay? So we're going to be dealing with subnets as we go through these parts. But when we get to the part 4, which I believe part 4 starts off at chapter 11, that's when we're going to actually be subnetting. There's some math involved with subnetting and whatnot, but don't get too scared. We'll get through it together, okay? Move this so I can actually see if there's anything going on in the streams tonight. Of course, I made everything a little too complicated over here. So disconnecting anything. All right. So that's what we're going to be getting into. So the most important thing that we're going to be, at least with chapter 8, what we're going to be really diving into is the understanding. We have to have an understanding of what a local area network is, so then we can understand VLANs, all right, virtual local area networks. And VLANs reside in your switch, all right, at least in in layer 2 switches, okay? So without that being said, what I kind of want to do is let's start off. Let us do, I guess we could just dive right into, things, I guess. Should we just dive right into things? Or should we do a quick review of the first couple of chapters? You guys tell me, what are you guys feeling? I gotta take this off. I am starting to get hot it's getting hot in here, so take off all your clothes. Don't get me started. All right. So let me just take that off real quick, guys, because it's getting a little warm in my room, and I tend to get these lights and everything on. It gets toasty pretty fast in here. So I don't want to pass out on you guys. That wouldn't be too funny to do on camera. Let's do this. Let's do a quick. We're not going to do the big. We won't do the big exam. We'll do a shorter exam. Okay, so yeah, my mic's on. So let's do a quick practice test of the first couple of chapters that we did, 1 through 7. We'll select just one, I guess, the one part of the exam. That way it's not too long, it's brief, and it just touched, so we can just keep everything at, pretty fresh in our minds. Let's come down to here. All right, let's do 1, 2, 3, 4, 5, 6, 7. Okay. Let's get this started. All right. Which of the following terms represent a layer 3 PDU in the OSI model, which includes the network layer, header, and the encapsulated data? So again, layer 3 OSI model. It even states it right here, network layer. So we're going to be dealing with packets, okay, guys? IP packets, okay? All right. IP functions at what level of the OSI model? All right. Network. All right. It kind of just answered that for us. All right. Refer to the diagram. The connections, the new connections that is going between campus 1 and campus 2. Router is required to provide at least 500 megabytes per second of bandwidth. The routers are located 3,000 meters away from each other. Which standard of Ethernet should be used in this situation? So we want to think big, so we're going to think Zulu, which is Z, 8023.Z. Okay. All right. The network in the figure uses Cat5 cabling with RJ45 connectors. Which of the following statements is true about the wires inside of the cable and the RJ45 pins that connect? So remember the type logic. All right, where we have, again, let's just draw it out. So just do this real quick so we can keep it in our minds. So we have, we'll have PCs and routers on this side, all right? And then also access points are on this side as well, all right? And then we have switches, all right? Switches, bridges, all right? And hubs all on this side, all right? When we connect, all right? When we connect a PC to a switch, all right, we're using straight through cabling. All right, but when we're connecting a switch to a bridge, all right, that's crossover cabling. Crossover cabling, yep. All right. that crossover cabling, okay? So every time, so when you, because what happens is that this is going to be transmitting on 1 bit, this is going to be receiving, so it can straight through that. But on this side, what happens is they're going to be both receiving and receiving on the same points. So that's why we have to use a crossover. That way, one can be transmitting on one pin, and the other one can be receiving on the other pin. Okay. All right. So the cable from S2 to S1, nope. S2 to 2, yep. So that one, we're gonna select 3. The cabling from PC1 to switch 1, both connect on, yep. And then the cabling from nope. And then S2 to S, yep. So remember, pins 1 and pins 3 on the crossover connect, and then pins 2 and pin 6 connect on the crossover, okay? Keep it moving. Remember, the bigger the core, that means multi-mode, because that light now bounces around. So let's go multi-mode. Which of the following data link layer protocols is used to encapsulate data link in a leased line? Data link in a leased line. PPP, HDLC. HDLC, okay? All right. How does the receiver of a HDLC frame know the type of the encapsulated, what has been encapsulated within the frame? All right. That is the type field in the header. The type field in the header. All right. Which protocol finds an unknown layer 2 address from a known IP address? Which protocol finds an unknown layer 2 address from a known IP address? That's our address resolution protocol. Okay. All right. When Cisco iOS command line interface is initially accessed via console telnet SSH with no privileges, which mode does the user get put into? So that is in user mode. Okay. All right. All host switch ports reside in VLAN 1 with no port security nor static MAC address table entries defined. Host B remains powered off, but all other hosts can ping each other successfully. Later, host B powers up. Later, host B powers up, and the user issues the ping 10.1.1.4 command that generates host B's first network traffic. Oh, never mind. Which answer describes how the frame is forwarded. So, host B hadn't fired up when all these other hosts had fired up, and these switches learned these things, MAC addresses, and so on and so forth. So, frame will be forwarded out S2, but not S3. Nope, it's going to use because you got to think host B is going to be sending out a broadcast, all right, to everywhere. So it's going to be flooded out all the switches. It's going to go to all these hosts, okay, but not itself, okay. The frame will be forwarded out. Yep, it's going to be forwarded out of there. The frame will be forwarded to host D. The frame will not be forwarded, so it's going to be these two, okay. It's going to go to everybody, la-di-da-di. All right. After power on, a frame arrives at a switch. The switch had not yet learned the source MAC address of that frame. Which action must the switch take in this case? The switch adds the destination MAC? Nope. Switch adds the source. Yes, it does. All right. Yep, and no. Okay. All right. In the exhibit, shows some configurations that's set in a text file. After adding this configuration to the switch, the user attempts to connect to username Fred and password Hope. Which of the following best describes the accuracy of the configuration, allowing a user attached to subnet 10.1.1.0/24 to SSH connect to the switch? Let's take a look. Host name, good. IP domain, good. Username, password, good. Crypto key generate, good. Mod, yep, okay. Interface VLAN 1. So here we go. They made a VLAN. They added an IP address to it. Very good. They now shutted it down. Line VTY to 0. Ooh, here we go. Here's our first mistake. They didn't put the login local, so their username password combination won't work. All right, and that way in transport input SSH telnet and SSH, that's telling that they can both use SSH and telnet. Okay. The configuration needs login local command. Yep. Okay. Got that one. Easy peasy, lemon squeezy. All right. Which answer encrypts the password that will be required of the user after they type the enable command. So remember, it's enable secret, okay? All right. Wrote the exhibit based on the information shown in the exhibit. What can be said of the configuration on gigabit 0-4's interface? Let's take a look, guys. We gotta select two answers. Gigabit 0-4 connected. It's half duplex, and it's been set to speed 100. All right, so auto negotiate's been turned off. All right, interface duplex has been auto negotiate's been turned off. So it's been set at speed and half duplex. Very good. For the diagram, both switches are Cisco switches. What should the state, speed, and duplex be of the link referred to switch 1? So switch 1, auto negotiate, fails because switch 2 does not. So switch 2 it's not auto negotiating. It's setting its speed at 1000, its duplex at full. So switch 1 will go to speed 1000 in full. All right. Let's see how we did. I think we did pretty good. We went 1000. We went 1000. Woo, 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 woo. All right. Cool. So that was a quick review. I know that was quick and fast and dirty, but that's kind of the point, guys. So let's keep it moving. All right. Let's get over to part 3, implementing VLANs and STP. All right. So this is just going to give us again, it's just going to give us a high overview of what we're going to be getting into as we dive into Chapter 8, Chapter 9, and Chapter 10. Okay? Part 3, implementing VLANs and STP. All right? VLANs, virtual local area networks. STP, spanning tree protocol. Okay? I know I'm not pointing at nothing on my board because there's nothing up there right now. All right. Part 2 of this book introduced the basics of Ethernet LANs, both in concept and how to implement the features. However, the two primary features discussed in Part 3 of this book, all right, virtual LANs, VLANs, and spanning tree protocol, STP, impact almost everything, okay? Everything you will have to learn about Ethernet LANs so far. VLANs allow a network engineer to create, separate Ethernet LANs through simple configuration choices, okay? After this, guys, we're going to go into Cisco Modern Lab. We're going to get, we're going to make a topology. We'll make some crazy VLAN stuff, okay? Again, I hope you guys have downloaded Cisco Packet Tracer so you guys can go along with me as we create some of these topologies now, okay? The ability to separate some switch ports into VLANs and other switch ports into other VLANs gives the network designer a powerful tool to create networks. Once created, VLANs also have a huge impact on how the switch works, all right? Which then impacts how you verify and troubleshoot the operation of a campus LAN. All right, STP, very important. STP and related. Similar to rapid STP, it's just rapid STP, RSTP, acts to prevent frames from looping. Remember when I talked about earlier that broadcast storm? All right, that's when you have a switch, just for poops and giggles, we'll take 3 switches. We're going to make redundant links between those 3 switches. You send one frame out of switch 1 over here, that frame's just going to go la-di-da-di everybody, all right? And it'll never stop forever and ever. All right? All right. Looping around that LAN. Without STP or RSTP in the LANs with redundant leaks, broadcast, and some other frames would be forwarded around and around and around and around they go. Local area LANs, eventually clogging up the LAN so much that it makes it unusable. Yep, you're going to blow your network up. Bomb. All right. The current CCNA 200-301 exam blueprint includes exam topics for configuration and verification of VLANs and related topics. However, the CCNA exam topics only mention, okay, this is very important, only mentions RSTP concepts rather than configuration verifications. All right. To that end, Part 3 opens with Chapter 8, which goes to the configuration verification depth with VLAN topics, followed by Chapter 9, which includes the concept of STP and RSTP. Part 3 closes with Chapter 10, which includes some RSTP configurations along with Layer 2 Ethernet channel configurations. All right, let's dive into Chapter 8, guys. Here we go. All right, some of the topics we're going to be discussing is describing switch concepts, MAC learning and aging, frame switching, frame flooding, MAC address tables, configure and verify in LANs, VLANs, access ports, default VLAN, connectivity, configure and verify into switch connectivity, trunk ports. Ooh, I love trunk ports. 802.1Q. All right, that's encapsulation. That's is that Cisco proprietary? I believe that might be, or that might not be. Well, I'll follow up on that one, guys. Okay, native VLANs. Okay. All right. So yeah, so far in this book, you have learned that Ethernet switches receive Ethernet frames. Remember, layer 2 switches deal with layer 2 MAC addresses. Okay. Make decisions and then forward those Ethernet frames. The core logic revolves around MAC addresses. Okay. They don't give a hoot about IP addresses. Okay, that's a router's job. All right. Or once we get into layer 3 switches, layers 3 can handle routing as well. All right. But for now, we're still dealing with layer 2 switches. They don't care about IPs. They only care about MAC addresses. All right. Yep. While true, the logic omits any consideration of VLANs. VLANs impact the switching logic for each frame because VLANs act as a subset of that switch port in an Ethernet LAN. Switches believe each Ethernet frame to be received in an identifiable VLAN, forward and based on MAC address table entries for that VLAN, and forward out those ports in that VLAN. This chapter explores those concepts. All right. As for the organization, yep. All right, let me just read that real quick. As for the organization of the chapter, the first major section of this chapter explains the core concept. These concepts include how VLANs work on a single switch, how to use Vlan Trunk to create VLANs that span across multiple switches, and how to forward traffic between VLANs using a router. So that would be the router on a stick. I love that name, just because I think it has the word stick in it, guys. I don't know why. I don't know. You tell me. But that will be the router on the stick topology. All right, and that's simply taking one router. All right, you take one switch. All right, you cut that switch up into multiple VLANs. Okay, VLAN 1, VLAN 2, VLAN 3. All right, you have each one of those off on their own subnet. All right. Again, we're just going to be touching on subnets and stuff like that on these chapters. We won't be taking a deep dive into them, but we're going to be mentioning them just because we have to, because we're going to be dealing with them now. This is when we get into why we're going to deal with those. Okay, so pretty much, you take your switch, you're going to cut it up to multiple VLANs. Each one of those VLANs are going to be on their own subnet, which is our own LAN. All right, they're going to be their own LAN. You got to think about it in that kind of perspective. Okay. All right, then you come over here to Mr. Router. Mr. Router does a neat job. This is when we get into sub-interfaces, okay? Sub-interfaces, all right? All right, we're going to break this one interface up to multiple interfaces, okay? But they have to correspond to these VLANs over here, all right? But we're going to make sure we have at least one native VLAN, all right? We need one native VLAN, and then we can use all the other VLANs, okay? We don't need to give this switch any IP addresses. You don't need no IP addresses. Nothing at all. All right. We just have to make sure that native VLAN matches what we tell our router is going to be that native VLAN, and then every other corresponding VLAN after that, all right, is corresponding to this switch as well. All right. We're going to do some trunking, some encapsulation, and then what will happen is all these subnets, all these different VLANs will be able to communicate with each other by using the router, okay? So it's just like talking out to the big internet, but we're going to be using it within our own. So we're going to be pretty much creating a wide area network within one switch. It's similar concept, okay? All right. I need more coffee. Bad enough I'm not talking fast enough yet. I guess I gotta talk faster. Woo! Woo! All right. Coffee, 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 coffee. All right. Let's keep it moving.
These highlights. I gotta do something about these highlights. Joe, you gotta take out these highlights. Damn you, highlights. No, I don't want to add a highlight. I want to take away a highlight. Undo. No. No. Yes. Oh, no. Why are you fighting me tonight? I love you so much. No. All right, I'm done. Screw you, highlight. You stay in there forever. All right. All right. Don't mind the highlights. Don't even look at them. All right. In a local area name, which of the following terms best equate to the term VLAN? Okay, which term best equates to a VLAN? All right, let's think. Is it a collision domain? I don't think so. Is it a subnet? Kind of is a subnet, but not really. All right. Is it a single switch? No. Is it a trunk? No. So it's B. It's a broadcast domain. Because, I say that, because if you don't mind my handy dandy beautiful artwork already, in this LAN, remember when we were talking about, when we first were mentioning Ethernets, okay? What happens is on that switch, got a switch, you got multiple, you got multiple interfaces off that switch. When that frame comes in, it's gonna flood it out all those frames. It's gonna flood out all those ports. Within that one, you gotta think again. This is inside of a local area network, okay? Because you gotta think about each VLAN being its own local area network, okay? So it's gonna be that address, okay? So it's gonna be using a broadcast, okay? All right. So broadcast. I'm gonna say 1. B. Let's move down. All right. Imagine a switch with 3 configured VLANs. How many IP subnets are required, assuming all hosts in and all VLANs want to use TCP/IP? Imagine a switch with 3 configured VLANs. How many IP subnets are required, assuming that all hosts want to use TCP/IP? So we have 3 VLANs. 3 VLANs. All right. They all want to be using TCP/IP. All right. They're all gonna be on their own broadcast. So what needs to happen? We're gonna need 3 IP subnets. 3 IP subnets. Okay. Let's go to 2. Let's say D. All right. Whoa. All right. Whoa. That's what I'm saying. Don't pay attention to these highlights. These highlights are old. This is very old stuff. Switch S1 sends a frame to switch SW2 using the 802.1q trunking. Which of the answers describe how switch 1 changes or adds the Ethernet frame before forwarding the frame to S2? So when a switch is using trunking, what happens is it's going to add, excuse me, woo, coffee time. Let's see, what's A said? Inserts a 4-bit header and does change. No, it's not going to change the MAC address. All right, it's not doing what a router is doing, okay? All right, inserts a 4-bit header and does not change. I think it is number 3. Let's just read the other 2 answers just for completion's sake. Encapsulates the forward, the original frame behind an entry, an entirely new Ethernet header. No, it doesn't add a new Ethernet header. And it is B. All right. Imagine that you are told that switch 1 is configured with the dynamic auto parameter. Now that's what we're going to be getting. So there's multiple different settings. There's multiple different trunking settings. Okay, multiple different trunking settings. Okay, there's dynamic desirable, dynamic auto. Then there's trunk. And then there's I believe it's non-negotiates the fourth one. But yeah, I believe there's 4 in all. We'll get into that. All right. Imagine that you are told that switch 1 is configured with the dynamic auto parameter for trunking on the 505 interface, which is connected to switch 2. You have to configure switch 2 with the following settings for trunking could allow trunking to work. So we have to choose 2 answers, okay? So out of all these, we have to choose 2 that would allow trunking to happen, okay? So on is not a setting, just an FYI. Access is not trunking, okay? When you set up something as an access port, that is not going to be a trunking port, a trunk port, okay? The 2 settings, so we have dynamic auto. So you have dynamic auto and dynamic auto. What's going to happen is one's going to be able to trunk, and the other one's going to be able to say, okay, I'll let you trunk. All right, and then we have dynamic desirable. Okay, all right. So those are going to be the 2 settings. All right. So we got B and C. Let's go with B and C. B and C. All right. All right. A switch has just arrived from Cisco. The switch has never been configured with any VLANs, but VTP has been disabled. An engineer configures the VLAN 22 with the name HANA VLAN command, and then exits configuration mode. Which of the following is true? Choose 2 answer. VLAN 22 is listed in the output to show VLAN brief. I believe so. VLAN 22 is listed on the output to show running config. I believe so too. VLAN 22 is not created. Nope, he created it. VLAN 22 doesn't exist on the switch until at least one interface has been assigned to that VLAN. Nope, it's on there. It'll be there. So we got, what do we got? A and B? Let's go with A and B. All right. All right. Which of the following commands identify switch interfaces as being trunk interfaces, interfaces that correctly operate as VLAN trunks? Choose 2 answers. Okay, so which of the following commands identify switch interfaces as being trunking interfaces, interfaces that can correctly operate a VLAN trunk? All right, so we have, so show interface, switch port. So interface trunk. Which of the following commands identify switch interfaces as being trunks? Let's just go with C and D. Let's shoot it. We're shooting from the hip on this one, but I believe I'm right. Shooting from the hip. Pa-pow! Let's do it. All right. Let's scroll if we can. All right. In a switch in a switch that disables VTP, an engineer configures the command VLAN 30 and shutdown VLAN 30. Which answer should be true about that switch? All right. A, the show VLAN brief command shows enlist VLAN 30. We got to choose 2. The show running config command shows enlist VLAN 30. The switch should forward frames that arrive in the access port. Nope. The switch should forward frames that arrive on the trunk port. Nope. All right. So it's A and B again. I'm going to say A and B again on that one. Let's do it. All right. Whoa. All right. The show interface gigabit 0-1 trunk command provides the three list of VLAN IDs. Which items would limit the VLAN that appears in the first of the 3 listed VLANs? The show interface gigabit 0-1 trunk command provides the 3 listed VLAN IDs. Which items would limit the VLANs that appear in the first of the 3 listed VLANs. No shut, switch port, trunk allowed VLAN. Command that provides a list of 3 VLAN IDs. I'm going to go with B. Let's do B. Is that your final answer? That's my final answer. All right. Let's see if I am full of bologna sticks or not. It might be full of bologna sticks tonight. I don't know. All right. We got B, B, D, D, B, B. I did get one wrong, so I got one wrong. A, B, B, C. Ooh, I got another one wrong. Ooh, no. We're going to have to go back and look at those ones. A and B, and then B, B. All right, so which ones I got wrong? So 7, no, 6. I did not, so 6, I'm going to write B. And then which other one? I got 4. Hey. Okay, let's go take a look at those real quick. Just erase all this booty stuff. I've never seen that one. But okay. Let's go down. And what's this other one? 6. Should have been C, B, and C. So show interface switch port, show interface trunk. Okay. I'll accept my defeat. All right. Let's keep it moving. All right. Virtual LAN concepts. A little bit of iced tea. Mix that with some coffee. I haven't had enough caffeine. All right. Before understanding VLANs, you must first have a specific understanding of the definition of a LAN, local area network. There's your definition. All right. For example, one perspective, a LAN includes all the user devices, servers, switches, routers, cables, and wireless access points in one location. However, an alternative, narrower definition of a LAN can help you understand the concept of a virtual LAN. A LAN includes all devices in the same broadcast domain. So there's that word again. A LAN includes all devices in the same broadcast domain. All right. A broadcast domain includes a set of local area network connected devices, so that when any of the devices send a broadcast frame, remember, when that PC, all right, when it does ARP or whatever it's going to do, it's going to be sending it out the FFFFFF, all right? It needs to send that broadcast frame to everybody, okay? So it can learn where everybody's at, all right? All right. A broadcast domain includes the set of local area network devices, so that when all devices send broadcast domains, all the devices get a copy of the frame. So from one perspective, you can think of a local area network and broadcast domain as being basically the same thing. Cool. Same thing. There we go again. All right. Using only default settings, a switch considers all interfaces to be in the same broadcast domain. All right, so that's pretty much stating when you say you just got a brand new switch. You got a brand new switch. Let me clear up my beautiful artwork. I know you guys love it so much. All right, but I'm gonna have to erase it. All right. And I have all my markies. Where'd all my markies go? Oh, they're in my pocket now. All right. All right. So you just bought a brand new switch. Here you go. All right. And you got multiple ports on this switch. All right. Again, the guys help me out. By default. All right. All these ports are going to reside in VLAN 1. All right. We're all going to reside by default in VLAN LAN 1. All right. You as the technician, the engineer, you got to go in and then you just simply configure, all right, these other VLANs, all right, and then you start breaking off which ports, which interfaces you want in those VLANs, all right. Again, depending on your network topology setup or how your engineer wants it to be. All right. By using two VLANs, a switch can accomplish the same goal as designed in Figure 8.1 to create two broadcast domains with a single switch. With VLANs, a switch can configure some interfaces in one broadcast domain and some into another, creating multiple broadcast domains. These individual broadcast domains created by the switch are called VLANs, virtual local area networks. Again, this is depicting one broadcast domain. All right, one broadcast domain. All right, these are switches. You know, say these are like unmanned switches, like bridges, for instance. All right, you can't go. You know, say you can't. There is no actual like management plane. There's that word I'm looking for. There's no management plane on this switch, so you can't go in. You can't configure it to have multiple VLANs. So you'll have to, you'll have to have multiple of these same type of switches to create multiple different broadcast domains. All right. Down here, this is showing a depiction of what you can do when you have a switch that you can have multiple broadcast domains. It's going to be split up into multiple VLANs. Okay, so that's where all this terminology comes from. So Mr. Dino and Mr. Fred on their own broadcast domain. So when Dino sends a broadcast message out, it's only going to go to Fred. It's not going to go over here to Wilma and Betty. All right. Only when Wilma sends a broadcast frame will it go to Betty. All right. It won't be able to go over to Dino and Fred. All right. And also, unless once we won't be able to communicate either to these other broadcast domains. Okay. There won't be any intercommunication between these two. So these two are on their own separate local area network, guys. Okay, so they're off on their own little world. All right, if you can think about it in that kind of an aspect. Okay, all right, let's keep it moving. All right, designing campus local area networks to use more virtual LANs, each with a smaller number of devices, often helps improve the local area network in many ways. For example, a broadcast sent by one host in a VLAN will be received and processed by all those other hosts in the VLAN, but not to host in a different VLAN. So exactly, Dino can only send to Fred. Fred can only send to Dino. Wilma can only send to Betty. Betty can only send to Wilma. Can't cross that. There won't be no inter-VLAN communication on this type of topology and this type of setup right here. All right. Limiting the number of hosts that receive a single broadcast frame reduces the number of hosts, the waste effort processing, so there's less processing for the unneeded broadcast. Okay. It also reduces security risk because fewer hosts see frames sent by any one host. So that's and again, it's reducing the amount of traffic within that actual network. Okay. At least that's the conceptual view of that. All right. It also reduced security risk by there are just a few reasons. So here's a couple. Let's get into the key points so we can get into some of the reasonings. All right. To reduce CPU overhead on each device, improving host performance by reducing the number of devices that receive each broadcast frame. 2, reduce security risk by reducing the number of hosts that receive copies of frames that the switch flooded. All right, broadcast, multicast, and unknown unicast. To improve security for hosts through the application of different security policies per VLAN. 2, and that's when you have, you break off your management VLAN, and then you have your multiple, like your production VLAN, your sales VLAN. Okay, you don't want sales and production to be messing on your management VLAN and whatnot, or vice versa. You don't want sales to interrupt your production network there. All right.
to create more flexible designs that group users by department. So there's that kind of same type of thinking. Or by groups that work together instead of physical locations. Solve problems more quickly because the failure domain for many problems in that same set of devices as those same broadcast domains. So that's just saying you'll be able to localize issues a lot faster. To reduce the workload for spanning tree protocol by limiting VLANs to a single access switch. All right. I turned on my notifications off. All right. Now we're going to get into trunking. All right. Coffee. All right. Creating multiple switch VLANs using trunk. Configuring VLANs on a single switch requires only a little effort. You simply configure each port to tell it that the VLAN number to which the port belongs. With multiple switches, you have to consider additional concepts about how to forward traffic between switches. When you are using VLANs in networks that have multiple interconnecting switches, the switches need to use VLAN trunking on links between the switches. VLAN trunking on the links between the switches. Okay? So, you got one switch over here. You got one switch over here. We're going to call you S1. All right? We're going to call you S2. All right? Again, here, they both have VLAN 10, VLAN 20. All right? VLAN 10, VLAN 20. All right. What it's saying is there has to be at least one link between those two switches that are being trunked. All right. And that trunking interface, usually you'll have it on per se like the native and then we're just gonna say native VLAN 1. All right. And then on that VLAN, you'll be able to trunk. You'll be able to use that trunk. So this one interface will be VLAN 1. This one, we're just gonna break this one out. VLAN 1. All right. VLAN 1 is gonna be set up as a trunk. All right, on both trunk. All right. So when VLAN 10 on this switch wants to communicate with VLAN 10 on this switch, or VLAN 20 over here, it can communicate. Okay. But by sending these messages through VLAN 1, all right? All right? So, when you're using VLANs in a network that have multiple interconnecting switches, the switches need to use VLAN trunking on the links between the switches. VLAN trunk causes the switches to use a process called VLAN tagging, in which sending the switch adds another header to the frame before sending it over the trunk. This extra header includes VLAN identifications, VLAN ID, field so that the sending switch can associate the frame with a particular VLAN ID. The receiving switch can then know in what VLAN each frame belongs. Okay. Figure 8.3 shows an example that demonstrates VLAN that exists on multiple switches, but it does not use trunking. So this is just stating, so if we weren't trunking, it's just pretty much stating that VLAN 10 would have to have an actual physical connection to VLAN 10 on this interface. So we're going to remove that actual. So for this concept, we won't have that native VLAN trunking. So we won't have that configuration. All we'll have to do is we'll have to separate an actual interface on each switch, and then assign that interface to VLAN 10. VLAN 10, and then VLAN 10 can talk to that switch over there, and VLAN 10 can talk to that switch over there. Same thing with VLAN 20. We'll have to have a separate port on each one of these switches, all right, that corresponds to VLAN 20 on both of them, so then only VLAN 20 can talk to VLAN 20, okay? So you would have to have two physical links between these two switches just so these two VLANs on these two multiple switches can then communicate with each other, okay? That's without trunking. All right, without trunking. All right. So this figure right here shows that demonstration. All right. The design configuration functions perfectly. So functions well. All right. For example, PC11 and Vlan 10 can send frames to PC14. The flow into S1 over the top link. But remember, one important thing. Vlan 20 is not going to be able to talk to Vlan 10. Even if, that's maybe how you want things to be. But you won't be able to communicate. There will be no inter-VLAN communication at all right, with this type of topology setup, okay? All right, VLAN tagging concepts. VLAN tagging creates one link between the switches that supports multiple VLANs, as many as you need, all right? As VLAN trunk, the switches treat the link as if it was part of all VLANs at the same time. The trunk keeps the VLAN traffic separate, so the frames in Vlan 10 would not be processed by Vlan 20. So, and vice versa. So that's pretty much stating if you were to send a broadcast out of one of the interfaces on Vlan 10, that broadcast per se wouldn't go here and wouldn't go here. It would send that broadcast to this switch though. It would still send it to this switch, but only to Vlan 10. Okay, same thing over here. If you had a broadcast that needed to go out with this trunk, it wouldn't send the broadcast out Vlan 10 or this Vlan right here. All right. So let's keep it moving. All right, multiple VLANs with trunk. All right. The use of trunk allows the switches to forward frames from multiple VLANs over the single switch connections by adding a small header to the Ethernet frame. For example, figure 8.5 shows PC11 sending a broadcast frame on PHA 01 at step 1. To flood the frame at switch SW1 needs to forward that broadcast frame to SW2. However, SW1 needs to let SW2 know that the frame is part of VLAN 1. So that is what it's using the VLAN ID to allow that to happen, okay? So that's what it's attaching. It's attaching that to the front of that Ethernet frame header, all right? All right. VLAN trunk is between that. All right, when SW2 receives the frame and it understands the frame in Vlan 10, SW2 then removes the Vlan header, forwarding the original frame out its Vlan 10, interface Vlan 10, all right? For another example, consider that in the case that PC21 sends the broadcast, SW1 sends the broadcast. It's just getting into more of how it's still, even with the trunk, still using the separation of the multiple VLANs, okay? All right. The 802.1Q and ISL VLAN trunk protocol. Cisco supports two different trunking protocols over the years: inter-switch links, ISL inter-switch links, and the IEEE 802.1Q. So remember how I mentioned, I assumed that the 802.1Q was the Cisco proprietary, but that is the IEEE standard. All right, so the IEEE standard for trunking is the 802.1Q. All right, the ISL, the ISL inter-switch links is the Cisco proprietary for trunking protocols. All right, Cisco created the ISL years before the 802.1Q, in part because the IEEE had not yet defined a VLAN trunking standard. Today, the 802.1Q has become the more popular trunking protocol, which Cisco not even bothered to support ISL in many of its switches today. So, like most things, Cisco makes it first. All right, Cisco makes. Did I freeze? I did. Cisco makes the standard first, and then the IEEE picks it up afterwards. And then once the IEEE picks it up, Cisco has a tendency to say, okay, now that they've created a universal standard for this protocol, let's drop our proprietary so then we can be universal to everybody else. So Cisco it's a great thing that Cisco does. So they create the standard, all right? The IEEE takes what Cisco's done, makes it a universal standard, and then Cisco says, okay, now that it's universal, let's drop our proprietary stuff, and then let's pick up the universal standard. That way, our devices, our switches, our routers can work with everybody else's stuff. That way, everybody's playing on this, playing with the same type of protocols instead of making things overly complicated. All right. Why we love Cisco. Cisco. All right. All right. While the ISL and the 802.1q tag each frame with the VLAN ID, the 802.1q inserts an extra 4-bit 802.1q VLAN header into the original Ethernet header. Okay, let's read that again. The 802.1q inserts an extra 4-byte 802.1q VLAN header into the original frame of the Ethernet header. Okay, so it inserts that 4-bit frame into the header. Okay, as shown in the figure. Okay, as for the fields in the 802.1q header, only the 12-bit VLAN ID field inside of the 802.1q header matters for the topic of discussion in this book. This 12-bit field supports the logical maximum of the 2 to the 12th power, the 496 VLANs, so 4,096 VLANs. So, if you were to do like a, so that's pretty much, that states how many VLANs you can usually create on one standard 6. It's 4,096. I believe you're allowed to go, there's like a range in between that you can't use or something like that, if I remember clearly. Yeah, something like that. But that's what it's stating right here. So you can have VLAN 4,000 if you want, all right, or 1,000. But in practice, it supports a maximum, it states right there, it supports a maximum of 4,094. Both 802.1q and the ISL use a 12-bit use 12 bits to tag the VLAN ID with 2 reserved values. That's 0. All right, so you can't have VLAN 0 and you can't have VLAN 4095. All right. I believe though, there are some, you can do some goofy stuff with VLAN 4095 on some other stuff. I believe so, but that's a topic for another day. All right, let's keep it moving. All right, Cisco switches break the range of VLAN IDs from 1 to 4094 into 2 ranges: the normal range, the extended range. All switches can use normal range VLANs with the VLANs from 1 to 1005. Only some switches can use the extended VLAN and VLAN IDs from 10 to 1006 to 4094. All right. The rules of which switches can extend VLAN depends on the configuration of the Vlan Trunk protocol, VTP. So VTP, Vlan Trunking protocol. Say that again. VTP, Vlan Trunking protocol. All right, one more time. VTP, Vlan Trunking protocol. Woo, that's good work. All right, which is discussed briefly in this section. Vlan Trunking configurations later on. Cool. All right. 802.1q also defines one special VLAN ID on each trunk that is native VLAN, the native VLAN default. All right, that gets back to what I was kind of stating over here. Excuse me. On each trunk native VLAN, the default VLAN. Remember, always the default VLAN. It's always going to be VLAN 1. Just by nature, that's the default. You can change that. You can change your native VLAN, but by default, it's VLAN 1. All right. By definition, the 802.1q simply does not add an 802.1q header to the frame in the native VLAN. When the switch on the other side of the trunk receives a frame that does not have an 802.1q header, the receiving switch knows that the frame is part of the native VLAN. Note, that's because of this behavior. Both switches must agree that on which VLAN is the native VLAN. So you have to, and you'll get some messages too. You'll get messages on your switches when you're setting up a topology similar to this. If you're trying to trunk and you don't have the native VLAN set up the same on both switches, you'll start getting messages
stating that you'll have a difference between the native VLANs, okay? All right. Forwarding data between VLANs. If you create a campus LAN that contains multiple VLANs, you typically still need all devices to be able to send data to all devices. The next topic discusses some concepts of how to route data between VLANs. The need for routing between VLANs. Okay. All right. Let's continue on. LAN switches that forward data based on layer 2 logic, as discussed so far in this book, often goes by the layer 2 switch. All right. Layer 2, we're thinking only MAC addresses. We don't give a hoot yet about IP addresses, all right? We're only still on layer 2. We haven't stepped up on that next ladder of IP addresses yet, okay? We are here very shortly, all right? For example, Chapter 5, Analyzing Ethernet LAN Switches, discusses how local area network switches receive Ethernet frames. A layer 2 concept looks at the destination Ethernet MAC address at a layer 2 address and forwards the Ethernet frame out some interface. All those concepts are defined by layer 2 protocol, hence the name layer 2 switches. All right. Layer 2 switches perform their logic per VLAN. For example, in figure 8.7, the two PCs on the left sit in VLAN 10. In subnet 10, the two PCs on the right sit in different VLAN, VLAN 20, with a different subnet. Note in the figure repeats earlier, but the switches are broken off in half, so it's just demonstrating the fact that they're on, again, when you have this type of topology, when you have one switch, you got multiple, you say you got VLAN, you got VLAN 10 over here and you got VLAN 20 over here, you're breaking up that switch so that only these VLAN 20 should be talking to VLAN 20. Only VLAN 10 should be talking to VLAN 10. All right, there is no communication back and forth yet. We haven't set that up yet. Okay, that FFF broadcast is only going to be pertaining to that subset, that VLAN. Okay, all right. As shown in the figure, when configured with some ports in VLAN 10 and others in VLAN 20, the switch acts as two separate actual switches. Yep, we covered that pretty well. I'll hammer that until I hammer myself to the death. Okay, all right. Now, my most favorite type of topology, the one I love making over and over and over and over again, the router on a stick topology. I guess the reason why I like remaking, or I like covering the router on a stick topology, because it gets into a couple different things. You start dealing with sub interfaces and whatnot on these routers and whatnot. All right, let's dive in. So, when including VLANs in a campus local area network, the devices in a VLANs need to be in the same subnet, following the same design logic. Devices in different VLANs need to be in different subnets. To forward packets between, here's that word. We just said packets, right? So now that we said packets, now we're thinking on the logic of IP, all right? To forward packets between VLANs, the network must use a device that acts as a router. The network must use a device that acts as a router. Routers forward packets, okay? You can use an actual router as well as some other switches. So that's a layer, that would be a layer 3 switch, okay? All right, but we're going to be just talking about routers just to keep things simple for now. These switches that also perform layer 3 routing functions go by the name multi-layer switch, or layer 3 switches, okay? This first section discusses how to forward data between VLANs using a layer 2 switch, and ends with a brief discussion on how to use layer 3 switches. All right. For example, figure 8.8 shows a router that can route packets between subnets 10 and 20. The figure shows the same layer 2 switch as shown in 8.7, with the same perspective of the switches being split into two different VLANs in the same, with the same PCs in the same VLANs and the same subnets. Now our router 1 has one LAN physical interface connected to the switches and assigns VLAN 10, and the second interface connected to the switch as assigned to VLAN 20. With interfaces connected to each subnet, the layer 2 switches can keep doing the same job for the packets between the VLANs, while routing can do its job routing packets between the subnets. So, let me read that one more time. With an interface connected to each subnet, the layer 2 switch can keep doing its job forwarding frames. Forwarding frames. Layer 2. We're dealing with frames, okay? Inside a VLAN. While the router can do its job routing IP packets, okay? Between the subnets, okay? So as it's pretty much Dino and Fred can now hook up with Betty and Wilma over here. And they can make little dino babies, all right? That's what they're going to be doing now, all right? They're going to be using this router so they can be hitting each other up on Tinder and whatnot now, all right? It's great. It's a whole new world, all right? Let me get some more coffee in my life. All right, more coffee. Coffee, 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 coffee. My wife tells me I drink too much coffee. I don't believe her. I don't see it as a problem. All right. Let's keep it moving. All right. The figure shows an IP packet being routed from Fred, which sits VLAN subnet. All right, we've covered this. I've hammered this pretty hard by now. All right. VLAN and VLAN trunking configurations and verification. Cisco switches do not require any configuration. Cisco switches do not require any configurations to work. They don't. All right, you can just take a switch, dump it in your network. You know, as long as it's pretty simple topology, it will be forwarding frames. All right. You can purchase a Cisco switch, install the device with the correct cables, turn the switch on, and wham, bam, thank you, ma'am. It works. All right. You would never need to configure the switch. It would work fine, even if you had interconnected switches, until you need more than one VLAN. All right, until you need more than one VLAN. But if you want to use VLANs, and most enterprise networks do, you need to add some configurations. All right. This chapter separates the VLAN configuration details into two major sections. The first section looks at how to configure static access interface, switch interface configured to be one VLAN only, therefore not using a VLAN trunk. The second part shows how to configure interfaces that use VLAN trunks. All right, let's keep moving. Creating VLANs and assigning access VLANs to that interface. This section shows how to create VLANs to give the VLAN name, assigning interfaces to the VLAN to focus on the basic details. This section shows example of using a single switch, so VLAN trunking is not needed. Assigning one VLAN, so VLAN trunking is not needed. Okay. For a Cisco switch to forward frames in a particular VLAN, the switch must be configured to believe that the VLAN exists. In addition, the switch must have non-trunking interfaces called access interface or static access interface assigned to the VLAN or trunk that supports VLAN. The configuration steps for access interfaces are shown below. All right. So here's the this is just walking. So once we get on the command line, you know, we're going to be jumping on Cisco Packet Tracer here very shortly. We're going to be diving in. We'll get a couple switches up. We'll walk through basic VLAN setup, and then we'll talk about communication, and then we'll set up a trunk type topology, and we'll talk about trunking on the command line as well. This right here is just walking us through some of the steps through, you know, on how to do it. Again, when I get on Cisco Modern Lab, it'd be how's this? It'd be better for us to do it on the command line, all right, than me trying to talk about it here, because you won't understand. It's going to be hard for me to go through and tell you where you're exactly at, because I have to tell you, or I mean, if you're experienced, you know where you're at, but I have to tell you where you're at to input the correct configuration. So the VLAN configuration example. So we'll set up VLAN 1, VLAN 2, and VLAN 3. All right.
and then we'll do that. This would be our show VLAN brief right here. We'll take a look at that. All right. This is just going through again more of the configurations. They're naming the VLANs now here. Yep. Very good. Adding ports to that VLAN. The show VLAN brief. All right. Here's the show run. So it's going to show it's the difference. So it's just demonstrating the difference between the show run command and what that's going to state. Obviously from the show VLAN brief. So the show VLAN brief is going to show you different information. Well, not different, but it's going to show you a better description of information. All depends on what you want to see and how you want to see it. You know what I'm saying? All right. And then here's our VLAN ID. This is going to show you some names and whatnot. All right. VLAN configuration, shorter example of VLAN configuration. Cool. It's just getting into the same thing here. Interface. So it's just this is just showing you the interface range. You can add obviously a range of interfaces to a particular VLAN. All right. So Vlan Trunk. Before showing you more configuration examples, you also need to know something about Cisco protocol and a tool called Vlan Trunk and Protocol. All right, VTP. VTP is a Cisco proprietary tool on Cisco switches that advertise each VLAN configured on one switch with the VLAN number command, so that all other switches in the campus learn that VLAN. So it's almost like, so it's like advertising. VTP is like advertising what one particular switch has to other switches. That's what VTP is pretty much doing. It's saying, I have VLAN 10 and 20. You should also have VLAN 10 and 20. All right. So that's what it's stating as a Cisco proprietary. This book does not discuss VTP as an end to itself for a few different reasons. First, this current CCNA 200-301 exam blueprint. It totally ignores VTP, as do the CCNP Enterprise Core and the CCNP Enterprise Advanced Routing Blueprint. Additionally, many enterprises choose to disable VTP. Okay. Also, you can easily disable VTP so that it has no impact on your switches in your lab, which is exactly what I did when building all of these examples in the books. However, VTP has a small impact on how every Cisco Catalyst switch works. Even if you do not try to use VTP, this brief section introduces enough detail of VTP so that you can see the small difference in VTP that cannot be avoided. All right, let's take a deep dive into VTP. All right, first, all the examples in the book and in volume 2, all switches that disable VTP in some small way. For much on VTP decades existed, most switches did not allow VTP to disable completely. On those switches, to effectively disable VTP, the engineer would have to set the switch to VTP transparent mode. With VTP mode transparent global configuration mode, the switches now have an option to disable VTP completely with VTP mode off global command. For the purposes of the book, configure a switch with either transparent mode or off mode disabling VTP. Note that the book transparent and off mode prevents VTP from learning and advertising VLANs configurations. Those modes allow a switch to configure all VLANs, including standard and extended range VLANs. Additionally, the switches using transparent mode or off mode list VLAN configuration commands in the running config file. All right. Finally, on particular note, if you happen to do a lab exercise with rail switches or with simulators and you see unusual results with VLANs, check the VTP status with the show VTP status command. If your switches use VTP server or client mode, you will find the server switch can configure VLANs in the standard range from 1 to 1005. The client switches cannot configure VLANs. Both service and clients may be learning new VLANs from one another and seeing their VLANs deleted by the other switch because of BTP. Woo! I would lose my Kool-Aid if that happened. All right. The show running configuration command does not list any VLAN commands. You must use the show command. So it's just saying BTP causes a little bit of a headache in some instances. All right. Note, do not change BTP settings on any switches that also connect to the production network until you know how BTP works and you talk to the experienced colleagues. Doing so can cause real harm to your local area network. For example, if the switch you configure connects to another switch, which in turn connects to a switch used in production local area network, you could accidentally change the VLAN configuration in another switch, but with serious impact to the operation of the network. You could delete VLANs, causing an outage. Be careful and never experiment with BTP settings on switches unless it and other switches connect to it have absolutely no physical link connected to that production LAN. So it's pretty much stating, don't mess with it on a real production network unless you know for sure you know what you're doing. All right, you're gonna stop messing things up, you know, and then the your boss there is gonna come down on you. Copy. All right. Vlan Trunk configurations. All right. So this is just going to get into the Vlan trunks now. Vlan Trunk configuration between two Cisco switches can be very simple if you just statically configure trunk. For example, most Cisco catalytic switches today support the 802.1q and not ISL. All right. That's the yeah. Man. How did I forget that word? Inter-switch links. Inter-switch links. There you go. You could literally add one interface subcommand for the switch interface on each side of the link. Switch port mode trunk. Switch port mode trunk. And you would create a VLAN trunk that supports all the VLANs known to each switch. However, trunk configurations on Cisco switches include many more operations. Include several options for dynamically negotiating various trunk settings. The configurations can either predefine different settings or tell the switches to negotiate the settings as follows. The type of trunkings. The IEEE 802.1q, ISL, or negotiate which one to use on switches that support both types. The administrative mode, whether it to allow trunks and always. The administrative mode, whether to always trunk, always not trunk, or negotiate whether to trunk or not. All right. First, consider the type of trunk. Cisco switches that support ISL and 802.1q can negotiate which type to use using the dynamic trunk protocol, DTP. All right, dynamic trunking protocol, DTP. If both switches support protocols, they use ISL. Otherwise, they use the protocol that both support. Today, many Cisco switches do not support the older ISL trunking protocol. Switches that support both types of trunking uses the switch port trunk encapsulate .1q, so the 802.1q, so the .q, you'll see that command. So when we get on the command line, you're going to see you're going to see this actual command, the switch port trunk encapsulate .1q. All right, you'll see the ISL. I believe you'll see the ISL command still on the switch images that I have in Cisco model. We'll take a look. Interface subcommand to either configure the type to allow DTP to negotiate type. DTP can also negotiate whether the two devices on the links agree to trunk at all, as guided by the local switch port administrative mode. The administrative mode refers to the configuration setting for all whether switch trunking should be used. Each interface also has an operational mode, which refers to what is currently happening on the interface and might have been chosen by DTP. Negotiation, which the other devices, all right, Cisco switches use switch port mode interface subcommand to define the administrative trunking mode as listed. All right, here's some key topics. So these are the four. All right, So you have access, always acts as an access non-trunking port. So access, non-trunking port, all right? Trunk, always trunks, all right? Dynamic desirable, initiates negotiation messages in response to negotiation messages to dynamically choose whether to start trunking, all right? Let me read that again. Initiates negotiation messages in response to negotiation messages to dynamically choose whether to start trunking, all right? Dynamic auto, passively waits to receive trunk negotiation messages, at which point the switch will respond to negotiate whether to use trunk, all right? So dynamic auto passively waits to receive trunking negotiation messages, okay? All right, for the example, consider the two switches shown in figure 810. The figure expands on the design shown in earlier with the trunks on the with a new trunk to switch and with part VLAN 1 and VLAN 3 on ports attached to SW2. The two switches use gigabit Ethernet gigabit links to for the trunk. In this case, the trunk does not dynamically form by default because both 2960 switches default to the administrative mode of dynamic auto. All right, they both by default both are on dynamic auto, all right? Meaning that neither switch initiates the trunk. Because remember, dynamic auto passively waits for trunk negotiating message. So if by default, and that's what it's stating, by default, the two switch port interfaces, by default, dynamic auto, all right? Which passively waits, all right? If you had one set, though, as dynamic desirable, what's going to happen is that it'll form a trunk, all right? So if you still had one as dynamic auto and you had one as dynamic desirable, it'll form a trunk. And if you still had one as dynamic auto and you had one as just mode trunk, it'll form a trunk, all right? All right, but if you had both at set at dynamic desirable, that'll form a trunk, all right? And obviously if you had trunk and trunk, that will form a trunk as well, all right? But dynamic auto and dynamic auto, they won't form a trunk, all right? And that's what's on there by default, all right? Which when one switch is changed to dynamic desirable mode, which one initiates the negotiation, the switch negotiation to use trunk. It just goes into that. And here's a nice, sweet demonstration of a trunk between switch W1 and switch 2. You got VLANs, all right, on each. So each switch has a VLAN 1 and a VLAN 3. Switch 1 has a VLAN 2 over here. But you have some trunking, some beautiful trunking going on here, guys, all right? It looks great. All right. Yep, all right. This is just going into some more of the command line that you'll see. Yep, the show commands, the show interface trunks, switch ports. Just going over some of that. Just show some more of the show commands. We'll take a look at these show commands too, guys. All right. All right, so here's a quick breakdown. All right. So access, all right? Access will pretty much be access all the way through, and you can't have it set on, you can't have one interface set as access, one interface set as trunk. It won't work, right? Dynamic auto, all right, access, all right, it'll just be an access port 2, and access. Remember, if you have 2 as dynamic auto, it still won't be a trunk, it'll still be an access, all right? But if you have one side set as a trunk to a dynamic auto, it'll become a trunk. If you have one set to a dynamic desirable, it'll become a trunk as well. Trunk, remember, can have an access port and a trunk port on the same sides, all right? No, I don't want to become famous and buy your followers. So we'll continue on. Dynamic auto trunk makes a trunk. Trunk and trunk makes a trunk. Dynamic desirable and trunk makes a trunk. All right. Access and dynamic desirable that will be still an access. Okay, so remember, access and dynamic desirable will still be an access, but dynamic desirable and trunk and dynamic desirable and auto, that will make a trunk. Dynamic desirable and a trunk will make a trunk. Dynamic desirable and dynamic desirable will make a trunk. All right. So there's that little quick breakdown. Implementing interface connected to phones. The next topic is strange, at least in the context of access links and trunk links. In the world of IP telephones, the telephones use Ethernet ports to connect to Ethernet networks, so they can use IP to send and receive voice traffic sent via IP packets. To make that work, the switch Ethernet port acts like an access point. All right. But at the same time, the port acts like a trunk in the same way. This last topic of the chapter works through these main concepts. All right, this is voice over IP and stuff like that, into that realm of things. We're almost done with this chapter, guys. We're doing pretty good. Is that a wet my whistle? Wet my whistle. All right. Let's continue on here, folks. All right, data and voice VLAN concepts. Before IP telephones, a PC could sit on the same desk as a phone. The phone happened to use a UTP cable with the phone connected to some voice device, often called a voice switch or private branch exchange, VPX. The PC, of course, connected using an unshielded twisted pair cable, UTP, to the usual local area network switch that sat in the wiring closet, sometimes in the same wiring closet as the voice switch. All right, so it's just showing a beautiful depiction of what it used to be like. All right, before IP telephones. All right, the term IP telephones refers to the branch of networking in which the telephone uses IP packets to send and receive voice as represented by the bits in the data portion of the IP packet. The phones connect to the network like most other end user devices, either Ethernet or Wi-Fi. The new IP phones do not connect via cable directly to the voice switch, instead connecting to the IP network using Ethernet cable and Ethernet ports like built into the phones. The phones then communicate over the IP network with software that replace the call setup and other functions of the VPX. The current products for Cisco that performs the IP telephone control functions are called Cisco Unified Communication Manager. Okay, so the Cisco Unified Communication Manager. All right, that's why when you see those IP phones, you're using UTP cable with RJ45 cable plugging right in the back of those phones now. All right, they're hooking right up to the network. All right, the older non-IP phones use the category of UTP cabling that often did not support 100 megabytes per second or 1000 megabytes per second Ethernet. Most offices use single UTP cabling running from the wiring closet to each desk. But now two devices, the PC and the new IP phones, both needed a cable from the desktop to the wiring closet. Installing a new cable to every desk would be expensive. Plus, you would need more switches. So it's just stating when the IP phones, instead of what they did, they figured out how not to, get more crazier with more cablings and more switches to add to the network. All right. So this is what it solved. All right. To solve this problem, Cisco embedded small 3-point switches into each phone. IP telephones have included a small LAN switch on the underside of the phone since the earliest IP telephone products. Figure 812 shows the basic cabling with the wiring closet connected to one end of the physical port to an embedded switch. The PC connects to the short patch cable to the other physical port, and the phone CPU connected, the internal CPU connected to the internal switch port. So it's showing in this description
the UDP cable connected to the phone, and then the PC connected to the phone. So this phone is acting is just a small switch in this instance. Okay. All right. All right. Sites that use IP telephones, which includes almost every company today, now have 2 devices off each access port. In addition, Cisco's best practices for IP telephones designs tell us to put phones in one VLAN and PCs in a different VLAN. To make this happen, the switch ports act a little like an access link for the PC traffic, and a little like a trunk for the phone traffic. This configuration defines 2 VLANs on that port as follows. All right, so it's going to get into a little bit of a nice little area here. So you have data VLAN, same idea in configurations as the access VLANs on an access port, but defined as VLAN, as the VLAN on that link for forwarding the traffic for the device connected to the phone on the desk. All right, typically the user's PC. Voice VLAN, the VLAN defined on the link for forwarding the phone traffic. Traffic in this VLAN is typically tagged as with an 802.1 Q header. So that's the trunking header there. All right, that's the 4-byte. All right, the 4-bit header. All right. So it's just depicting the Cisco best practices here. All right. All right. Data and voice VLAN configuration. Conjoining a switch port to support IP phones. Once you know the plan voice and the data VLAN IDs required just a few easy commands. Making sense of the show command once it is configured, however, can be challenging. The ports act like access ports in many ways. However, with most configuration options, the voice frames flow with an 802.1 Q header so that the link supports frames in both VLANs on the link. But that makes for some different show command outputs. 888 shows an example of the configuration in the case. All four switch ports, FAR 01 to FAR 04, begin with the default configurations. The configurations add the new data and voice VLANs. The examples then configure all 4 ports as access ports and define the access VLANs, which also called the data VLANs when discussing IP telephones. Finally, the configuration includes the switch port voice VLAN 11 commands which define the voice VLAN used on the port. The example matches figure 813 using the FAR 01 through FAR 04. So here we go. It's just showing us some of the command line over here. All right. Very good. Good stuff. All right. Note, CDP, which is discussed in the CCNA 200-01 official sort guide, device management program, must be enabled on an interface for a voice access port to work with a Cisco IP phone. Cisco switches and routers enable CDP by default, so its configurations are not shown here. So CDP is Cisco Discovery Protocol. Cisco Discovery Protocol. Okay, so that is a protocol in which you can have when you're in a LAN or a WAN, CDP, pretty much you can start figuring out what's going on, the devices and stuff like that that's going into your network, right? CDP though is something, or LLDP, which is the CDP is the Cisco proprietary discovery protocol, and LLDP is the universal discovery protocol, right? Those are something you might want to disable on your edge devices, okay? Those are, like I said, those are something you might want to disable on your edge devices, okay? So that information isn't going any further than your actual network. All right. Let's continue. So this is just going into the configuration here for the voice VLAN setup. All right. Cool. All right. Just want to show them some of the show commands. Very good. All right.
doing the same thing. Some of the troubleshooting now. A switch data plane forwards process depending in part on VLAN and VLAN trunks. The final section of this chapter focuses on the issues related to VLAN and VLAN trunks that could prevent LANs switching from working properly. Focus on a few items not yet discussed in the chapter. In particular, this section examines the steps of an engineer can take to avoid issues. Okay, step 1, confirm all VLANs are both defined and active. So make sure they're defined, make sure they're actually in your switches, and they're actually active and not shut down. Okay. Step 2, check the allowed VLAN list on both ends of each trunk to ensure that the VLANs intended to be used are included. Okay, so it's just saying that you got to make sure that you have the same type of setup on your switches here. Okay. All right. Step 3, check for incorrect trunk configuration settings that result in one switch operating as a trunk with the neighboring switch not operating as a trunk. All right. Step 4, check the native VLAN setting on both ends of the trunk to ensure the settings match. Okay, remember, you're going to start, if you have mismatching VLAN setups, you're going to start actually getting messages, all right, on your switches, all right? All right, access VLANs, undefined or disabled. All right, switches do not forward frames for VLANs that are not known because the VLAN is not configured or has not been learned with VDP, or the VLAN is not known. But it is disabled, shut down. This next topic summarizes the best ways to confirm that a switch knows that particular VLAN exists, and if it exists, determines that the shutdown state of that VLAN. All right. First issue of whether the VLAN exists on the switch. A VLAN can be defined to a switch in 2 ways, using the VLAN number global configuration command, or it can be learned from another switch using VTP. So you can make a VLAN by the global configuration mode, the global command of VLAN yada yada number. All right, so when you're in the configuration mode, VLAN, you know your number right there. All right, so VLAN 10, VLAN 20. All right, or using VTP. All right. As mentioned in earlier chapters, the example in this book assumes that you are not using VTP. If you discover that a VLAN does not exist on a switch, simply configure the VLAN as discussed as earlier in this section. Okay, cool. All right. In addition to checking the configurations, you check the state of the VLAN as well as whether it is known to the switch using the show VLAN command. All right, these show commands are so useful. You're going to rely on these show commands as you continue on. Well, as we continue on, these show commands, going back and just checking on your configurations as you go along, you're going to get into a habit of just always running these show commands just because it helps you out so much. You know, you can only remember so many things as you're just blasting through this command line. All right. The switch iOS gives you 2 similar configuration methods, which to disable. All right, so you have the shutdown and no shutdown. Remember those commands when we can shut down interfaces. We can do the same thing to our VLANs as well. We can shut them down. We can no shut them down. All right. And here's just some of the statuses on the show VLAN. So here's the show VLAN brief. All right. We can see active. All right, but it's shut. All right, active. All right, it's there, but it's shut. All right, but active. Okay. All right, and this is showing that on VLAN 10, there's only actually one. They've only got one port, one interface to that, and that's 502.13. All other VLANs are showing that they don't have actually any interfaces on them currently. Okay. The output of the show VLAN brief command also lists the state of the unsup in of the reserve VLANs 1002 and 1005 with unsup meaning unsupported. All right, so unsupported VLANs. All right, mismatched trunks operational states. Trunks can be configured correctly so that both switches use trunks. However, trunks can also be misconfigured with a couple different results. Either both switches do not trunk, or one switch trunks and the other one does not. Both results can cause problems. The most common incorrect configuration, which results in both switches not trunking, is the configuration that uses the switch port mode dynamic auto. So that's, remember this. So that's the default option. So the switch port mode dynamic auto. All right. Remember, when you have two interfaces defaulting as dynamic auto, they won't create a trunk. All right. Both switches. The word auto just makes us all want to think that the link would trunk automatically, but this command is both automatic and passive. So automatic and passive. Remember, it's a passive command. As a result, both switches passively wait for the other device or the other link to negotiate, but they won't. All right. So it's just showing you the show interface. Here's our show interface on our device here, and it's just stating that it's set to dynamic auto. Okay. All right. A different incorrect trunking configuration has an even worse result. One switch trunks sending tagged frames while the neighboring switch does not trunk. So the neighboring switch discards any frames it receives that have a Vlan tag in the header. When this combination of events happen, the interface works in that the status of each will be in the up. All right, so it's not going to. They're both going to be on the up. All right, traffic in the native VLAN will actually cross the link successfully, but those frames, the frames that have no, so those frames have no VLAN tag. However, traffic of the rest. So what it's stating is the link with the native VLAN. So that traffic will actually flow, but anything that's tagged with the 802.1q header, all right, with that VLAN tag ID, those frames will be dropped by that other switch. So that's what that's stating right there. Okay. Figure 814 shows the incorrect configuration along with each side trunks in which does not. All right. So you have one with trunk mode on and the other one with it's being an access port. Okay. The side that trunks, the SW1 in this case, enables trunk using the command switch port mode trunk, but also disables dynamic trunk protocol DDP negotiates using the switch port negotiate command. S2 configuration also helps create the problem by using one of the two trunking options that relies on DDP. Because S1 has disabled DDP, S2's DDP negotiation fails, and S2 chooses not to trunk. So that shows that right there. All right, so that's just showing mismatch options. All right. Figure shows what happens when you using incorrect configurations. At step one, SW could forward the frame for VLAN 10. However, S2 would review any frame that arises with any 802.1q header as an illegal because the frame has an 802.1 header, and the switch treats it gigabit 0-2 port as an access port. So the switch W2 discards the 802.1q frames received by the port. So it just gets rid of those frames. Boop. See you later. All right. The trunking issue shown here can be easily avoided by checking the configurations and by checking the trunk operational state mode on both sides of the trunk. The best command for checking trunk-related facts are shown as show interface trunk and show interface switch port. Just be aware that the switches do not prevent you from making these configuration mistakes. So you got the keys to the castle, man. You make these mistakes, it's gonna let you make these mistakes. All right, it's not gonna prevent you. That's all it's stating. All right. The supported VLAN list on trunks. A Cisco switch can forward traffic for all defined and active VLANs. However, a particular VLAN trunk may not forward traffic for a defined active VLAN for a variety of other reasons. You should learn how to identify which VLAN particular trunk port currently supports and the reasons why the switch might not be forwarded the VLAN trunk. All right. So it's just getting to more troubleshooting. So it's just looking at more of the show commands. And these are show interface. Yep. Sorry guys, I got my window open. All right. Mismatch native VLANs on a trunk. Unfortunately, it is possible to set the native VLAN ID to different VLANs on either end of the trunk using the switch port trunk native VLAN ID command. If the native VLANs differ according to the two different neighboring switches, the switches will cause frames sent in the native VLAN to jump from one VLAN to the other. Okay. For example, if a switch SW1 sends frames using the VLAN 1 on an 802.1 trunk, switch 1 does not add a, because remember, on a native VLAN, the 802.1.q does not add that 4-bit header. It doesn't add that VLAN ID header to the native VLAN. Okay, so if switch 1 VLAN is set at 1 and it sends it through that trunk port, it's not going to add that VLAN ID because it's on its native VLAN. All right, so it gets received at switch 2, and switch 2 doesn't acknowledge VLAN 1 as being its own native VLAN. All right, that's where that issue is going to come into play now. Okay, all right. For example, if switch 1 sends a frame using the native VLAN on an 802.1 trunk, switch 1 does not add the VLAN header as it normally for the native VLAN. When switch 2 receives the frame, notice that no 802.1 header exists. Switch 2 assumes that the frame is part of switch 2's configured native VLAN. If switch 2 has the configured to think VLAN 2 is the native VLAN on the trunk, switch 2 would try to forward that receiving frame to VLAN 2. The effect of the frame being sent on one VLAN but not being believed by the other. So it's VLAN. It's called VLAN hopping at that point. All right. All right. So here's just some key topics. So we covered basic VLAN concept, reasons for using VLANs. All right, diagram of VLAN trunks, 802.1q header. All right, options of switch port mode commands. Expect trunking results based on the configurations of the switch port mode. Definitions of data, VLAN and voice VLAN. Summary of data in voice VLAN concept, configurations and verifications. Analyzing the three VLAN list in the outputs of the show interface ID trunk command. All right, some key terms. All right, we have 802.1q trunk administration, trunking administration mode, trunking operational mode, VLAN VTP transparent mode, layer 3 switches, access interface, trunk interface, data VLAN, voice VLAN, native VLAN, default VLAN, and static access interface. Woo! Man, I felt like that was a wicked long chapter today. Woo! All right. Boy, they're busy tonight. All right. So just some command references, and we're going to go over this. We're going to be jumping over to Cisco Modern Lab right now. All right. So we have here's just some of the these are the command line commands you're going to see very shortly. All right. I might have to. You know what I'll do? Man, should I spin? I got Cisco Modern Lab already spun up. See how my server's doing. Maybe we'll spin up my my packet tracer. We'll see. All right, let's jump over to my other view here. Just drop my stuff real quick. Move my coffee. How's everybody doing? Hope everyone's doing good. All right, let's move that right here, and move you over here. How's everybody doing? Ah, it's a little dark. Turn the lights real quick. Breaking everything without knocking over all my stuff. Yeah, beautiful. I just want you to know you're my favorite girl. I know. I got a beautiful singing voice, guys. You don't have to tell me. It's all right. It's all right. It's all right. It's all right. All right. Cool beans. All right. Grab some more tea. Alrighty then. So, let's get jiggy with it. Put you up to the side real quick. Let's grab some switchies. Some these. Let's get you fired up. All right. Give that a second, guys. I'm just gonna check out, make sure. I'm gonna be chatting over on YouTube real quick. I still gotta get that worked out. Let's see, chat. Yep. Okay, good. Very good. Very good. Cool. All right, so that's gonna fire up. Let's get zoomed in here so we can see. Woo! All right. Let's get this started. So, what we're gonna do is, I'm gonna come over here, grab my handy spandy little maca. We're gonna set up some VLANs real quick. So this will be Vlan 10. All right. And this will be Vlan 20. All right. We're gonna give it some easy peasy IP addresses. So this will be 10.0.10. Let's say 2, and you can be 10.2, 1. Yep, cool. 10.0.20.1, and you can be 10.0.20.2. Right, and they're all going to be in the /24 subnet mask. That really don't matter right now, but that's just what it's going to be. All right. So just like in the chapter, like we went over, so what we're going to first do is we're going to take this switch, we're going to cut it right in half. Hooah! We're going to ninja slice it. Sweet! All right. And we're going to cut it off to 2 separate VLANs first, all right? Just so we can go over some of the first initial commands, all right, of that. And then what we can probably do afterwards, we can add another switch to the topology here. All right, and yeah, we'll just go from there. Let me PCs to get that started. Pick this up. Oop, no. So we're going to do always our first command. All right, enable. All right, this is going to bring us right out to enable mode. All right, I'm going to go into configuration terminal mode. All right, configuration terminal. So now we're here. And let's just give this a nice easy name of switch. Nothing too crazy. Okay. And now what we want to do, all right, we're going to keep this very right to the T on how the book goes over to create. So we're not going to add, we're not going to be adding IP addressing to the switch, nothing like that. It's just going to be simply a VLAN. We're just going to be making VLANs, okay? So let's make our first VLAN. So we're going to say, we're going to give it the, so we're in the global configuration mode, okay? Stated by how where we're at right now. So right here, so we're in the switch config mode, okay? All right, so we went from user mode, all right, all right, to enable mode. From enable mode, we moved ourselves into configuration, all right, global configuration. So that's where we're at right now, okay? All right. So when we're there, we give ourselves the VLAN command, okay? All right, so we're going to give it the VLAN command. We're going to say VLAN 10. All right, that's it. Let's give it VLAN 10. And if you notice, what we just did is we moved from global configuration mode to the VLAN sub configuration mode. Okay, so now we're in the VLAN sub configuration mode. Okay, stated by how your thingy changed. Okay, very good. All right. Now we can give this a name. And a name usually it just helps us. It'll just help just keep things neat and organized. So we're just gonna say, what do you want to call this? Let's call this let's call it 6. Oh wait, I gotta give it the name. All right, so name 6. All right, so we're just gonna give it the name, the command name, and I'm making that name sale. So the command name is the actual command. All right, I'm giving it I'm just stating that I want to name it. Okay. So now I'll exit. All right. Now it's actually saving that right now. That's why you see that it takes that second to go into the next, to go back to global configuration. Okay. So again, I'm going to give it the command VLAN. All right. Now I'm just stating I want to create. VLAN 20 is not currently on there. I want to create VLAN 20. So I'm going to create VLAN 20. Again, I'm just going to name it. All right, I'm going to give it the name command. And we'll name this production. Again, I'm giving it this name. You can name it whatever you want to name it. All right. Cool. All right. And now let's exit. All right. Now it looks like all of our PCs came up. So let me see. Yeah, there's 4. Luckily enough, we have 4 interfaces on this when I booted it up. Because by default, this image has 4 interfaces by default. So it's got gigabit interface 0-0, gigabit interface 0-1, 0-2, and 0-3. So luckily enough, I have 4 interfaces. I should have used some forethought though, and maybe added a couple more interfaces so when we add the next switch, we won't have to erase and do this all over again. But hey, whatever. Sometimes I go too fast. Eh? All right, so we're gonna hook this up to the gigabit 0. All right, gigabit Ethernet 0-0. All right, create that link. Go to the next one. Come over here. We'll hook that one up to gigabit Ethernet 0-1. So we know those two. So this one is in gigabit Ethernet 0-0, and this one is in gigabit Ethernet 0-1. So we're going to have to go back into our switch now and put those 2 interfaces into VLAN 1. And we'll do that next. All right. So let's just continue on. We're going to put you in 0-2, and you, last but not least, we're going to put you in gigabit Ethernet 0-. All right. So what we're going to do is now we have to go into the Vlan interface. Okay, so we're going to give it the command. All right, interface Vlan, and now All right, we're going to move into that Vlan's interface. Okay. Now what I'm just going to do is I'm just going to simply add these VLANs to this interface. So I'm just going to give it the switch port. Oh, I know. Hold on. Let me exit out of there. Oh, never mind. All right. Let me exit out of there. Let me take a step back. So, let's go into interface, range. I had to take a step back. I'm forgetting a couple steps. So, interface, range. Now we're going to say gigabit interface 0-0 to 0-2 to 1. And that's going to put us in that range mode. All right. So I made a mistake and I'm going to take that back. So instead of moving into the interface VLAN mode, all right, we have to move into the actual interface mode. All right. And then we give it the switch port mode access. And then switch port access VLAN 10. All right. And now we can exit out of there. And then we move back into the other interfaces. So switch port, no, interface range. All right. Gigabit 0-2 to 3. All right. And then we're just going to get the switch port, mode access, switch port, access, VLAN, VLAN 20. All right. And we'll exit. Let's go back to exit, and then we'll do the copy. Running config. Start. Let's assign some IP addresses to our PCs real quick. Don't mind, these are just Linux commands, guys. .2/24 device equal 0. .21/4 0. That's .2/24. Cool. Now we have our addressing, guys. All right. here, just make sure our address seems good. Our address seems all set up now. Here. All right. So, like I said, so when we come over here, let's try to ping our neighbor, which is 10.0.10.2. All right. We can ping our neighbor. Hello, neighbor. All right. Let's try to ping though 10.0.20.1. We cannot. All right. We're all hooked up to the same switch and all. We cannot. Come over here. We'll ping our neighbor 10.0.20.2. Same thing. We can successfully ping our neighbor over here. All right. But when we try to ping somebody outside of our actual network, we cannot. All right. So what we've done is exactly on what in the beginning of the book, what it describes is we took a switch and we divided that switch into two subnet domains. All right, two broadcast domains. Okay, so they're in their own broadcast domain and they're in their own broadcast domain. Okay, there is no communication between these domains right now, these broadcasts, these subnets. Okay, all right, and let's come over here. Let's do a show. Vlan brief. All right, and let's take a look at some of the information that we got. So we have the name. All right, Vlan. So it's going to give us the name, the number. We have the name. So we have Vlan 10, which is our sales. We have Vlan 20, which is our production. All right, they're active. All right, our interfaces: gigabit 0-0, gigabit 0-1, gigabit 0-0, gigabit 0-1, and then on our production one, gigabit 0-2 and gigabit 0-3. All right, so this is our show Vlan brief. Okay, so we can see that what we've just set up is what the beginning first part of the chapter discussed. You can take one switch and you can split it up to different broadcast domains, and then you can have that communication between just those broadcast domains. Okay? All right? Very good. All right. So take that, and now what I want to do, and what I'll have to do next, because of that, I have to add more interfaces. But let's add another switch. Oh, I know what I could do, so I don't have to delete all that. I can these guys. Then another these guys. All right. So I'm gonna turn this guy off. All right. I'm gonna undo this link here. Delete the link. Yeah, buddy. I'm gonna go back to the switch. All right. Let's go back to configuration terminal mode. All right. And I want to go into, that was interface gigabit 0-3. So let's go into interface gigabit 0-3. All right, and I want to put that back. I want to put that back into Vlan 1. All right. Now let's do a show Vlan brief. All right. So what we did is we've taken that VLAN, we've taken that interface, gigabit 0-3, that used to be in the production VLAN, okay? And I removed it and I added back to the native Vlan 1, all right? Now, why I did that is now I'm gonna use that to hook up to this, well, to this switch right here, all right? And then that's going to hook up to this switch, and then we're going to create a trunk, okay? Just erase all my stuff real quick. All right, so I'm going to take this unmanaged switch, and then I'm going to make a link to this happy guy over here. Yep, very good. And then he's going to make a link to this happy guy over here, and I'll do it on the same link, just so it can all look the same. It don't matter. At this point, that doesn't matter, but I'm just going to do it anyways. You fired up now. Just give that a second. And now what we'll do is we'll set up on VLAN 1, we'll set that up as being our trunk. And then we're going to add a couple more PCs. Okay, so we'll add a couple PCs to this cool little thingy. Let's grab some more PCs. So what we're going to create now is the ability, so we can now, these PCs that are in their own broadcast domain will be able to communicate with their fellow department on the same broadcast domain. Same thing with VLAN 20. We're going to do the same thing. We'll have VLAN 20 over here. So we're still going to use desktop 3 here with that same IP address that still falls into that VLAN 20 broadcasting, okay? And over here, VLAN 10, we're going to set up VLAN 10 over here as well. And we'll set up these desktops with that same broadcast domain subnet, okay? All right? And then you'll see that they'll be able to communicate over here, and these guys will still be able to communicate, okay? Then what we'll do is we'll have to add a router in here, okay? And when we add a router to this nice little topology, we'll be able to route between those VLANs from there, okay? All right? Let's, come on, Betsy. Fire up for me. These fired up too at the same time. I can turn you back on. You, I'm going to keep off just for a moment. Right, since you came up first, I'll add you some IP addressing. Cisco sudo IP 10.0.10.3 4. Let's do this quick. Sudo and 10.4/4. Nice. Do 10. Okay, we'll name it sales. We'll make VLAN 20. Name that production as well. And let's move into interface range. It'd be the same ranges, so it'd be gigabit 0.0 to 1. And it'd be switch port. Access, switch port, 10. And then let's move into interface range. Gigabit 0 dash, what is it? 2. What is it? 0 dash. It's just 2. For food access. Access 20. Is it? There. Now let's move into interface 2-3. This one will be switch. Cap 10. Three. Encap Q. Switch 4. Okay. Got that up now. And I believe that's it. Get you fired up. All right. So, if all else went right, should be able to have some communication. Let's find out. And look at that. So right now, PC4 is pinging PC10 all the way over there. Okay. All right. Let's come over here. And 10.0.20.1. Oh. I gotta log into it again. I forgot I shut it off. Let me just make sure the IP address saved. Didn't. Okay, no big deal. Sudo IP address add 10.0.20.2 4. Cool. All right, so let's ping 10.0.20.1 and look at that. So what we're doing is PC3 is still, it's pinging PC1 over here. Stop that. Look at some IP addresses. All right. So 10.0.20.1, and that's what this PC was just pinging 10.0.20.1. So what we've effectively done is we've created a trunk port. Okay. Do show Vlan brief. All right. So again, on PC on the switch over here, you have the VLAN 10, which has these two PCs in it. Okay, VLAN 20, which has this PC in it. Okay, same thing as on this switch over here. Do show VLAN Bridge. Same similar type of setup. Okay, sales. All right, on these two interfaces. Okay, and then the production. Okay, on that one. Okay, then let me just fix it up here. So we can do the show switch port. Show trunk. There we go. So look at those show commands real quick. So let's look at show interface. Gigabit. And then each trunk, the trunks are on gigabit 0-3. Take a look at what we got going on. It's up, yeah, cool. And here's our encapsulation. Okay. And let's take a look at show Vlan. Vlan 1 active on gigabit Ethernet 0-3. Remote span. What trunk information? Give me trunk. I say give me trunk information. Want to get some of the commands, the show commands for trunk, and that's all I want to get quick for us, so we can take a look at those commands as well and see how those look on the show interface, show interface, gigabit 3. All right, there we go. So here we go. So port gigabit 0-3. So this port right here going to this unmanaged switch. Remember, this is an unmanaged switch right here. All right. It's on 802.1q trunking on native VLAN 1. Okay. VLANs allowed for trunk. So it's just stating that these are all the VLANs allowed for our trunks. VLANs allowed and allowed for active management. So so here we go. So it's showing us the actual VLANs that we have allowed, all right, for the trunking purposes. It already tells us where we have VLAN 1, VLAN 10, and VLAN 20. So there's a nice command right there. Show the show interface, all right, and then we're going to identify the actual interface. So gigabit 0-3, which is this interface right here, which is going to this right here, and I'm going to give it the trunk command. Okay, so that's a nice one. And now let's run another show command. So show VLAN. We're going to give it the ID. We're going to say 1. see if this one comes over. That's just going to show that same thing. Let's do. I just want all the show commands. The show commands are the most important things, guys. I think we already showed. I think we already did this show command. Show interface gigabit 0-3. What? Oh, there you go. Here's some others. Cool. All right. So here we go. Switch port enables switch administrative mode. So we have administrative mode trunk, operational mode trunk. All right. Administrative tracking trunk and encapsulation .10Q. All right. Operational .1Q. Negotiation on trunk on. Okay. Access mode VLAN 1. All right. It's saying that our default. We have it as the default. Very good. VLAN tagging enabled voice. So voice VLAN. So we don't have any voice set up yet on it. Cool. All right. So those are the. So here are the couple of. Let me write these two down for you guys. So that was the show interface. Show interface, and then whatever interface. So this was a simple. That was the gigabit 0-3 interface, and that was the switch port command. All right, and then the other one that we did that showed up some really good stuff. That was the show interface, and then same thing, just the actual interface. Gigabit 0-3 trunk. Let me just leave those two up there for us, okay? So here's our nice two commands right here, okay? And then we'll go back over to this switch now, and we'll take a look at the same thing. So we'll do the do show. Let me exit just to give us some context sensitive help. A little bit easier for us to do this. Show interface gigabit 0-3 trunk. Same thing. So on this switch now, same thing. It's showing us the exact same setup, guys. All right. 1, 10, and 20. 1, 10, and 20. Cool. Very good. All right. So we have that. All right. Now, though, let's try to ping desktop 2 over here. And remember, desktop 2, that's at 10.0.10.2. So PC3, totally different one. That's at 10.0.20.2. So I'll run the IP address for you guys so you guys can see 10.0.20.2. All right, and I'll do the same thing on this one. All right, 10.0.10.2. All right. Now, so as you can tell, we cannot communicate with that PC as it stands. Okay. Now, if we add Mr. Router to our topology here, this will create the router on a stick for us guys. The router on a stick. All right. Get that. Once he fires up. Guys have any questions? Let me just swing over to YouTube real quick. Guys have any questions? you know, feel free to ask, guys. Feel free to ask me. I'm here for you guys. I'm yours. I am yours. Just checking at my YouTubers real quick because I know I got a couple over at YouTube. And again, guys, when I get another monitor, and I apologize for this just slight inconvenience for now. When I get another monitor, I'll be able to monitor, obviously, all the chats simultaneously instead of having to bounce between it on my phones for right now. But that'll come. That'll come. So, all right, I'm just gonna now I'll switch back over to Twitch real quick. Ooh. That is today's date. All right. Cool. All right. All right. This should be firing up right now. Now on the router, what we're gonna have to do is we're gonna obviously have to assign the router an IP address, and then this is where it gets neat. And this is why I love this configuration, because this will now turn into the router on the stick topology, where we start breaking sub interfaces off on our actual router's single interface, and that will then be able to route the traffic between our VLANs. So here we go. Let's dive into it. So I'm gonna make my connection here. Good. Say no to this. Just give it 1 second. I'm just gonna close my window. It was hot now, but now it's freezing again. That should quiet down too a little bit. I'm hot when I'm cold. Yes, in my nose. My beard, it's so pretty. It's my filter. Come on, we're almost there. All right. Cool beans. Let's move into enable mode. Gonna blast out one more thing before. Come on, I know you're not done yet. Okay. Slow on me. Ah, there. Come on. Come on, Vincent. You can do it. All right. All right. So we're gonna move into our interface. Gigabit. There it goes. That's all I need to do. Now our gigabit 0-0. Remember, that was the interface that we attached to this unmanaged switch. Now, I'm not going to attach it to any of these switches because what this unmanaged switch is, what it is acting almost like a bridge, I guess I can say. And since I have the native VLAN on both these switches going to this one bridge right here, I'm going to be able to do something pretty cool with it. So I'm going to go into that interface, all right? And I'm just going to assign it an IP address. So I'm going to say IP address, right? And I'm going to give it the IP address of 10.0.0.1. Now I know that's not in the range in either one of these subnets, but it doesn't really matter. So, and I'm going to say 2.5.2.5.0. All right, shut. Okay. Now, what I have to do from here, right, cool. Now I'm going to move into interface, gigabit 0-0. All right, you're going to say, oh, it's almost the same interface. But wait, I'm going to do the .1. This is the gigabit 0-0's first sub interface. Okay? Now, go into that. All right? Now, what I'm going to assign this is this is going to act as the pretty much like it's going to encapsulate. It's going to be like the interface that's going to be speaking on VLAN 1, and it's going to be encapsulating that data to the router. All right, and then that router is going to make a decision, and then because I got to add a couple more sub interfaces to that, it's going to make a decision where to route those packets off of the other interfaces, the sub interfaces that I'm going to assign it afterwards. So, all right, so I'm going to say encapsulate .1q. Give me some context sensitive help. I'm going to say 1, and I'm going to say native. All right, all right. Now, if you had assigned, all right, if I had assigned a different native VLAN to this native VLAN topology, then I would be given this a different native VLAN. But I'm not, because I assigned, because it's running, everything is running off of native VLAN 1 currently. Okay? All right. Now I'm going to assign it an IP address. All right. And I'm going to say 10.0.1.1, 255.255.255.0. All right. Give that a no shot. Cool. Now I'm going to move into interface, gigabit 0-0.10 now. Okay? Encapsulate Q10. All right. And I'm going to give that an IP address. All right. I'm going to say 10. Remember now, now we're into the VLAN. So I'm going to say 10.0.0. Do that again. .0.10. And I'll give it the IP address of 100, just to stay without, within that range, whatever. 255.255, not 258, 255.0. And no shut. Okay. Now I'm going to move into interface, gigabit 0-0. Can you see the pattern here? .20. Okay. Encapsulation, .Q20. The address, 10.0.0.20.100. 255.255.255.0. Give that a shot. Okay, that's it. Yeah, and I believe that wraps everything up. Do it right. Let me just give this. I don't think you even need a loop back up this. Let me just check something real quick. There we go. All right. Now that we have that set up, now let's go back over here. And what was this IP address over here, guys? Again, that's 10.0.20.2. Let's try it out. Hopefully this works. I hope it does. It might not, because now I need to add default. I might have one issue because I need to add the default gateways now. But let's just test it. Yeah, because I don't have default gateways. That's fine. All right, so sudo IP route to 0.0.0. violates DHCP. Oh. Just had to assign default gateway real quick. Change you. You. And our actual router now. Okay. Check out real quick. Hold on, guys. Okay. Still. Ping the router, right? Yeah, maybe we can ping the router. 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 The yeah. UP. Do show route time. Route. Duplicate is like adding DHCP instead of letting everything do its own addressing. You know what to do? You know what I'm gonna do? Hold on, guys. Hold on. Let me do this. IP TCP. I'm gonna fix this real quick. Watch this, guys. This is gonna be magic. Sudo down. Stay. Run this on everything. Watch. Hold on, guys. Paste. Deleting all the IP addresses and all its information that it has on it stored real quick, guys. Just because every time I tend to do, when I statically, this is the problem when you statically address it. Things get wonky, so. Say, CLC. Network 10, 0, 5, 2, 5, 2, 5, 2, 8, 0, 10, 100, exit, P, cool.
Hey, Daddy.
Buddy?
Streaming?
Yeah, buddy. How you doing?
How long was it?
I'm still streaming.
So, can I see pickle chips?
Huh?
Can I see pickle chips?
Yeah, all right. Zero. Equal. $20. 100. Not bad. Exit. Now let's come back over here. Just do show run. Want to check the configuration on the router real quick, and then I'm going to re-engage these. Yep. Good. It's good. That's good. So now we're gonna run sudo if up Okay. And then I should, all right, so we've got an IP address. So I'm gonna run that. Now remember, the only reason how I got an IP address is if it can communicate with the router. So it's actually gonna allocate addresses in all the, that's the, beautiful. Right, we're getting the correct IP addresses. And this one should get it in its own range. Yep, beautiful. 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 All right, so we've got IP addresses now. Oh. Now we got it. All right, so that's why I hate statically addressing things. I hate statically addressing things. Every time I statically address something, I can never, it's just, Linux is sometimes, always been in my butt to add the default gateways and all that happy stuff. But once you have a DHCP server, so apologize for that. So I just had to go back to, all I did was, I hope you guys kind of understood all I did was I created a simple DHCP pool. All right. I went into all these PCs and I erased all that IP information I had put in there. I erased it, totally took it off. I didn't want it. It's garbage. You know, I knew it wasn't going to work. I knew I was going to run into issues. And I then, due to how I have the sub interfaces connected to the VLANs, it knows where these PCs are at. And it addressed these PCs to the correct, not only to the correct VLAN, but now it's got the correct default gateway information. Now I can ping 10.0.10.1. I can ping, I have inter VLAN communication now, okay? All right, same thing. We'll go over this PC and let's check out its IP address. All right, same thing. It's got the correct, so 10.0.10, all right? Go to this one, IP address, 10.0.20. So it got, yes, you're gonna say it's the same IP address as was. Yes, because I didn't manipulate the thingy. It just was going through the, when it addressed thing, it just went one after another. I could set up a exclusion pool where it would exclude an address range out, and it would have changed those IP addresses. But because I did it automatically anyway, I went through that same type of range. That's the reason why it seems to be the same IP range. But it was the router then, it was the router's DHCP server that gave this address now, not me. I didn't do it. I erased everything I did. So this was, now we have inter VLAN communications, okay? And we didn't change anything on these switches. Nothing at all. We didn't have to do anything else to these switches that we already didn't have. All we did is now when this information's passing through the switch, it's going over here, and now the router is routing that, all right, to where it needs to go, all right? Now it's creating an intercommunications between the actual VLANs, okay? Yeah, that's a pretty good demo. I love doing this stuff, guys. I love labbing because labbing for me, it helps me, continue to learn. So, again, I hope you guys, download Packet Tracer. Start going through Packet Tracer. start making these labs. You can make this exact lab in Packet Tracer in, you know, one, you know, maybe because we still have to come up with a plan for Thursday and Friday. Well, Thursday we're probably going to be doing a complete review of part 3, because remember, we're only going to get, tomorrow will be chapter 9, and chapter 9, let's just do a quick review of what tomorrow shall bring for us. Chapter 9, let's get to there it is. Chapter 9 is going to be getting into the spanning tree protocol concepts. Okay, so spanning tree protocol concept. Okay, and what I'll probably be using Cisco Packet Tracer tomorrow. That way I don't explode my computer when I make a broadcast storm. Because we'll hook up three switches together. We'll make redundant links, and then what we'll do is we'll send a frame through that, and we'll create a broadcast storm in Cisco Packet Tracer. I won't do it again on Cisco Model Lab, because Cisco Model Lab will affect my actual computer. But we'll do it in Cisco Packet Tracer, and you can see, we'll look at how it simulates that packet going around and around and around and around. And yeah, we'll go from there. So tomorrow will be spanning tree protocol concepts, and we'll dive through that. That's a fun one, guys. Spanning tree protocol is pretty neat. We'll see how when we enable spanning tree protocol, how it picks the root bridge, how it picks the designated root ports, and which ports become designated root ports and which don't, and how the cost and all that, how it figures out the cost to figuring out that information. And yeah, so that'll be chapter 9, and then chapter 10 will be RSTP, which is rapid STP, and then Ethernet channels. So that'll bring us to Wednesday. And then Thursday we'll do a complete review of part 3, which would be VLANs, Vlan Trunks, STP, and then RSTP. So that'll be Thursday. We'll do a big review, and then Friday I would like to do a lot of labbing. So by Friday, guys, I hope you guys out there can download Cisco Packet Tracer by Friday. And then as we're just labbing it up on Friday, if you guys have any questions, that would be like the perfect day for us to together as a group do some labs. You guys can ask questions. We can work through a configuration such as this, you know, and I'll be using Cisco Packet Tracer along with all of you guys. So don't feel as though I won't be, because I will be. Like I said, I have the VM. I have another VM that I have Cisco Packet Tracer on. I use a separate VM just because of the streaming issues, and I don't want my main computer to crash while I'm streaming. So I use Cisco Packet Tracer on a separate VM. But it'll be the same Cisco Packet Tracer that you guys will be using. So again, so hopefully by that time you guys can have Cisco Packet Tracer up on your own. And then we can just lab it up on Friday. We'll do a couple different types of labs. We can work through, you know, some questions, and go from there. So with all that being said, guys, yeah, I'll see you guys tomorrow, same time, 5:00 p.m. Eastern Standard Time, same place. All right. I love you guys, and I appreciate all you guys' time. I want to tell you from the completeness of my heart, thank you so much for you guys for watching. I hope you guys got something out of this today. I always do. And yeah, I love every single one of you guys. Have a good night, everybody. Mwah! Good night, everybody.